Hello everyone, so I rendered 100 and something frames, so this is the result that I have for now. I have some issues here, but we'll fix those. Apparently the motion blur issue with a constant topology mesh and variable topology mesh doesn't work properly, so the motion blur is applied a little bit differently on two different meshes. So you have the liquid mesh being a little bit late to the party in some places, so you have those interpenetrations, like the flickering here where the mesh goes into the liquid mesh goes into the inside the body of the creature. So you see there's like a, as if there was like a like a delay between those meshes. So this is due to the motion blur. So I might probably, because last time I didn't render the motion blur, I tried it here. So this may be an issue, but we can manage without it, or we can just try to fix this issue later in the second version of the render. So yeah, this is the render that we have here. So yeah, the only big problem is the liquid flickering. So we'll find some solution here. This is the raw render, there's no effects on it, so in the compositing stage we'll have a lot of improvements visually. So I checked in PD Player from KS Group, I checked the passes, and yeah, we have that space between the mesh, the liquid mesh and the body. And yeah, the passes look alright to me. There's some reflections there. There's some subsurface scattering, the normals here. Then we have the UVs in case we want to add some more textures on top of the creature in post. So the Z depth, and the cryptomat passes. So this is cool. For the next version of the render, we'll optimize stuff, and we'll add the wet map on the ground, which will be a very light addition to the existing render, but it will be there. It might improve some things. Let's close this, and let's go into calculating and baking the wet map as a bitmap sequence. So we'll close this guy, and let's go back to our OBJ context, and I baked the wet map as a geometry, which is colored. As you can see, there's a trail left by the creature here on the ground. It fades over time, but it's there. So now let's make a null here and point this null to the output of the wet map, the geometric with wet map, because we have the color baked into the points. So wet map geo. What I'd like to do now is make a cop network here. So this cop network is going to let's do a copnet, and inside the copnet we'll make a VOP to cop generator. So this guy is going to be the core of our baking setup. So let's make like a color. This is just like a solid in any compositing software. So the cop network is like a compositing context, so you can do 1,000 million trillion things here. It's an amazing context, and it's barely used by artists. I've seen just a few instances where it was used almost at its full potential, where people are completely like texturing stuff in it procedurally. So this is incredible. So we'll connect this color to this VOP cop generator, and we're basically using a solid color just to add some information to that solid color. This color layer, like this solid color, will just be as a base, will serve as a base, and will define which resolution we're going to use in the output image. So let's override the size, and the size that I used for the wet map was this. It's quite huge. We may probably not use that much. Let's make it half here because it's overkill. But this size respects the ratio of this plane that we created here. So I think this is enough. And let's dig into the VOP to cop generator. And what we're going to do is sample the pixel coordinates here by using float to vector. We have two variables here, x and y. These represent the two axes of the image, of the solid color, or the solid basically layer. And so let's create a XYZ distance, and we'll be sampling data from the from an external file, which is going to be our null that we created before. But before this, let's go back here, and we have this wet map placed in space, and it represents the location of our grid, on top of which we have this monster walking. So in order to use the CopNet, especially in 2D space, we have to have this plane in UV space. This plane has already UVs that we created earlier, and what I'm going to do is switch it to UV space, and this is really easy. I basically make an attribute triangle. So all the sampling operation inside the CopNet should be done in UV space. So we'll set the position as the UV. And you can see that our plane just shifts in space and becomes one by one. One in Y and one in X. So this is the UV space of our object. If we click space 5, we'll have the UV space here. So this is the same basically representation of the geometry, but in UV space. So now let's go to the CopNet here, and we have this input geometry from the XYZ distance. So we're going to sample our geometry like this. So we'll be using an expression which is called op backticks, op full path. So I'm going to use the full path of our guy here, and we're going to use out wet map geo and backtick like this, and it should be, oh, maybe we don't need that thing here. I hope I'm not mistaken here. Yeah, it looks like it's all right. Yeah. So let's switch to the composite view. So basically this composite view will display our operation here, but we didn't do any operations yet. We didn't output anything, so let's do that, because we started doing the XYZ. But I want to sample the color, the CD attribute from that geometry, and bake it into this flat plane in the UV space. So let's do a prim UV, primitive attribute basically, and connect the prim and the UV, and then we're going to sample this. The file will go into the input here, and let's connect the color that is output through a vector to float, because we have the RGB channels here, and we want to connect all of these guys properly, and the vector to this preview. All right. Yeah. So yeah, that looks all right. And let's go back here, and there's like an error, unknown parameter input. Oh yeah. So let's name it file. Oh, because I renamed it. Oh god, I just have to redo the whole thing. But yeah, let's copy again. Let's do the honors and write it again. Op full path. 2 dots again. Out wet map geo. Yeah. So now the path is correct. And you can zoom in and see what happens here. So we have our wet map baked into this plane, and this is great. The resolution is correct. It will match the ratio of our plane. And let's do a ROP file output, and we'll connect this, and we'll bake 300 frames strict. Yeah, basically it all stays the same. We'll save it into text wet map v01 text wet map v01 exr, and the plane scope RC. We don't need the alpha. I don't really care about it, because we just want to bake the color. So let's save some space with that. And yeah, the output, this ROP comp, we'll just use the resolution set in this color solid. And let's save this guy. And maybe, you know what, I'm gonna maybe apply a blur here, which is an effect, just a simple blur. Maybe not a Gaussian, because it's going to be a little bit heavy, or not. Might be alright. Let's do a 3.5 or something like this. And what's funny is that you can apply a different filter on different axes. So on X you can apply a Gaussian, and on the on the Y you can apply a Mitchell or something. And this is funny. So yeah, that's cool. Maybe 4. See what the other ones do. But I usually use either box or Gaussian for this kind of filtering operations. So let's bake this guy, and I'll come back when it's done. So the baking is done. Now we can go back to our scene, and we're going to work on the ground. So basically, the ground that we have is not the same ground that doesn't have the same ratio, like size and positioning. So let's object merge the ground that we had, the wet map geo that we had. So geo wet map out wet map geo. So now you can see that. Let's make a null basically for the this one is going to be pointing to this. Maybe let's leave it like this so the cop network works. And this guy is going to be pointing to our flat plane with the UVs. So this is the outlet wet map plane. Let's call it plane. So in the Joey ground, I called them Joey, so his name was Joey. Face is Joey, this symbiote. So let's import our plane here. So we're importing the plane that we get here, and we have our original plane on which we have the texture. What I want to do is, how do we transfer that wet map? How do we apply the texture, generated texture sequence to this grid when it was initially applied to this grid? So I want to steal the UVs from this guy, and yeah, I want to. It has already the UVs, so I'm not going to play around. But what we'll do is just attribute rename this guy, and we'll attribute rename our UVs and make them UV2 instead of UV, because we already have the UVs on this guy has already a set of UVs. I don't want to change them. I just want to add another UV attribute on top. So I renamed this guy to UV2. So if you check the information here, you can see that there's UV2, and we'll attribute transfer this guy to this guy. So now we have a set of UVs. Let's UV quick shade this guy, and we can apply a texture and see it in the viewport. I hope in the future SideFX allows us to work with textures in the viewport properly, because it was always a pain to do that. So yeah, this guy, and we'll just transfer the UV attribute here, UV2, points to points, and UV quick shade. But the issue with the UV quick shade is that it just transfers, applies the UVs only on the applies the image on the first set of the UV, and there's no way to change it. Usually you'd have to dig into the SOP and change stuff. But I removed disabled the attribute rename and transferred the regular UVs, and you can see that it's applied where it should be. So let's go back and set here. Set this guy, put this guy on, and transfer the UV2. Remove the UV quick shade. This will happen just once, so you see that the timeline scrubbing is really fast. So let's set a null here. Out ground. Usually I set an output node, but let's set an output node just in case, which will be here. So yeah, that's practically it. We have 2 UV sets here, and we can attribute promote this guy if you want, but it will not make a big difference. Attribute promote UV2 point to vertex, and just for the beauty of it, having UV and UV2 in the vertex attributes. So that's it. And now we can go into our shading. Well, let's disable the fluid for now. Let's go into the camera and maybe hide the body and go into the matte context and work on the ground texture. And in the ground texture, we'll be going here and importing the UVs, the texture. So in order to use that animated texture, we'll use a specular layer first. We'll connect this guy to here, and the specular layer is going to be a little bit rough, 002, and let's copy one of these guys, name it text wetmap, disconnect this transform, put this guy into the specular, and I want to load that sequence that we got. Show sequences as one entry, load this guy, and we have to check reload here. And this checkbox in Octane means that if your renderer here, the Octane wrap is set to full scene reload, it will go and update those animated textures. So this texture will evaluate at each frame when you check the reload button here. So yeah, this is it. But the other thing, we have to set the proper UV projection. So projection mesh UV, it was renamed recently because it was just projecting UVW. And yeah, we'll set this to 2 because the UV set for this texture is the second UV that we transferred from that simulated wet map grid that we solved with the solver and the wet map attributes. Let's see what that does. Go into the out. Check the override camera resolution. I want to render half of it, which means a quarter of the whole image. Alright, so let's see in the matte context, if we disconnect this layer, what happens? Not much happens, but yeah, and maybe we'll have to increase that power here. Maybe, let's say something like this. Go check the reflection here, and maybe it will be more visible when we go to another frame. Yeah, as you can see that like we have like some kind of wetness happening here. So if we disable this, you'll see that it appears. Let's disable also the depth of field. You can see that there's something happening here. So let's decrease the roughness. Sometimes you have to boost the power of this map just to fake it a little bit. But yeah, if you don't increase it, it will be really invisible. So yeah, let's leave it at 100 here, and let's show up, enable the Joey body, full reload this guy, see how that works. Yeah, so we'll have some wetness happening here. You'll see that there's a trail that is left. And let's disable this. Actually, let's see if the issue that we have comes from the motion blur. Let's enable the Joey fluid. Reload. We have that wetness happening behind that tail, so that's interesting. So I've full reloaded this thing. See what happens. So yeah, the liquid doesn't have the issue right now, but it will have it on some other frames. Actually, it has it here on the ground. And let's go to the out, to the Octane wrap and disable the motion blur. And let's reload this image. But I had this issue before, and yeah, it was a really huge mess. Yeah, even like it was the same frame. I don't know if you noticed when we switched from the motion blurred version to the non-motion blurred version, there was like a shift in the frame. But let's try to override this. Actually, let me see again the render. I want to see on which frames we have the issue, so we can compare when it's with and without the motion blur. So we have this issue here, for example. You see the penetration here, the frame 110. So let's switch to the, well, close enough, 110. We have this, so we'll have this issue here with the flickering. So it will render in the image and you'll see that issue arise. And let's do the same. Let's try with the shutter time at 0. I mean, yeah, well, the shutter time, it will be the length of the motion blur, so it will be weird if we do this. But if we disable the motion blur, I'm pretty sure this issue will just disappear. Well, except the ground, because that is really a physical problem. The drops, they don't slide off the surface. So as you can see, we have that issue go away when when the motion blur is off. So let's go into the ambient occlusion. See the gap that we have here. Let's go back to our the material that we use for the body. And let's do that offset again. 45. To offset the displacement. And yeah, we have this issue now in a really different way, because yeah, the thing here is that let's try to do some. Yeah, so the ray epsilon parameter here in the Octane um, defines the ray offset basically. When you have some issues with really close objects where when there's like double faces, for example, and you don't really want to fix the geometry and you have to just render this thing really fast, and you have double faces, like superposed faces in the same space, taking the same space and position. You want to get rid of that issue, you have to increase that ray epsilon. Almost every renderer that I know has this option. Helps you really turn off, fix issues with penetrations. But the other problem is the ground penetration problem. And let's see if the displacement here is going to be a little bit different if we just change some parameters here. So yeah, it eats out the, so basically we offset this guy too much, so now it's kind of floating above the ground, as you can see. So yeah, we get, with this mid-level you can control the offset of the displacement. And yeah, you can get it close to what you need, but the issue will remain. This color change and penetration between the meshes is something that needs to be fixed. So I'll search for a solution for this, and I'll come back to you. But let's now just optimize the simulation, because I really want to get rid of those particles that are around, like outside the camera view. So this is really important, and we'll remesh the mesh with that optimization in mind. So let's turn off this guy, and we have the wet map. We fixed some of the issues, but the only issue remains with the penetrations on the ground and the color flickering. So you can see already that the liquid here is penetrating already the mesh, the liquid mesh, but it's fixable. I'm pretty sure of it. So let's go back to our OBJ context, into the system where we meshed our liquid. So you remember that we did an attribute VOB that pushes out the particles outside the collision geometry using VDBs, which was great. And yeah, let's do an optimization here. So in order to do the optimization here, we'll need to make a UV attribute. This is one of my favorite ways to kill particles. It's make my own system that kills particles. So let's make an attribute triangle. And let's optimize this thing. There's a bunch of particles here that I don't want to see in the view. The camera is kind of final. Will not have any changes done to it. So we can proceed with the optimization setup. So we know that the camera is somewhere here. So I want to clip the particles that are beyond that field of view, the frustum of the camera. So let's make a UV texture first. And the UV texture will be a dynamic UV texture. There's this bug now in Houdini 19 when sometimes when you work a lot on a scene, every time you put a node after an evaluated node, it will just evaluate it again. So even if you click again on the node, like I'm doing here, you see that it reads back again the file caches and reevaluates the particles push out VOP. So let's choose perspective from camera, and we'll choose our camera main. So now our particles have UVs, which is makes no sense in any other software. And yeah, and you cannot really see them because it's a vertex attribute, but we'll set it to point. And now we have UVs, so they're kind of invisible. And what that means is that the particles that are here, they have values between 1 and 0 and 1 in both axes. So they're kind of laid out in the UV space. But the particles that go above, like further outside the frustum, they'll have values above 1 and below 0 on both axes. So this is the part which we'll use in our attribute wrangle. So basically, I want to make a parameter, like a condition, which removes the particles if they're outside the camera frustum. So if VFX, so in the x-axis, I really, if in the x-axis the value, the UV value in the x is lower than 0 minus channel, let's say offset, and we'll make this into brackets. We'll set this into brackets, and another condition, like, or maybe, yeah, and another condition. We'll copy this whole condition here. And this 1 plus the same offset, and it should be bigger. I mean, if it's less, yeah, if it's less than this and bigger than this, basically. What I'm doing here is just checking if the particle has a UV attribute in the x-axis bigger than 0 and plus something, yeah, minus something, and lower than 1 plus something. So I'm kind of extending that 0 and 1. And if it does, I mean, let's do the opposite as I did before. So if it's lower than that and higher than that, we'll remove, let's open the brackets, remove point, and 0 pt num. And we have some issues here. Yeah, maybe the syntax is not correct. Remove point, geo handle 0, and yeah, all is supposed to work. VFX. Oh, yeah. Oh, yeah. Another set of brackets. Yep. So let's do the channel thing. So UVX, VUVX, UVY, 1 plus, or yeah, we just should be doing this as a condition, yeah, sorry. Because no particle will satisfy both conditions. A particle cannot be outside the left, like the, sorry if you go into the camera, a particle cannot be on the left of this camera frustum and on the right at the same time, so this was my problem. Yeah, so this is cool, and that's probably what I want to do. I can also do the copy this guy, and also like enter, and do another one, but this time with the Y. Yeah, so it's going to eat some of those particles. There's another method of doing this. It's using the from NDC function in VEX and using a volume created, which will represent the frustum of the camera. But I prefer this one because it's really fast to evaluate. Don't forget that VEX evaluates super fast. It's multi-threaded, live compiled language, which is incredible. So yeah, if you cut this portion, you'll see that we have some particles killed here. So let's go back, put it here, and you'll see that it evaluates and kills those useless particles that go below the camera frustum. So the funny thing is that we have that offset that I was talking about. The offset will define how much extension you need. So we need some extension. This method will not work, for example, when you have a bunch of scattered buildings, for example, and the scattered buildings, they project shadows onto your scene. And if you clip those buildings like outside the camera frustum, they will stop projecting the long shadows on the ground. So you'll see that the buildings disappear because the shadows disappear with them. So the render will be really funky. And this is the scenario where it's not going to work. But in our case, when we use this camera frustum, we scrub further on the timeline, you can see that we killed a bunch of particles here. So this is crazy. Like, let's see, we have 10 million particles here, let's say. This is overkill, obviously, but maybe I abused a little the values on the flip solver, but that's okay. I can allow myself to do this on this machine because there's a lot of RAM, so that's all right. But you can go lower than this. The 0.00015 that I used as a resolution in the flip is overkill, way overkill. Anyway, yeah, so we had 10 mil in the beginning, and we have like 9 mil, like 10 mil here, 10 mil 6 here, 9 mil 2 here. So let's go in the first frames. So in the first frames, 4 and 7, 4.7 mil, 4.6. And yeah, here, for example, yeah, it should clip a bunch of those. 9 mil, 9 mil 3, 6 mil 9. So you can see how much it clips. But the interesting part is that our particle fluid surface will just surface these particles, and the mesh is going to be lighter. I prefer to do the mesh to apply this wrangle on the particles before the meshing, because you can do it on the mesh also, but this would require you to mesh the entire particle count, the original particle count. I prefer to do it before the meshing because the meshing will be faster afterwards. So yeah, this optimization will help us speed a lot the rendering, because yeah, we're making a lot of, we're cutting a lot of that geometry out. So this one's going to be called opt camera frustum, and you can do clip a lot of stuff with this. You can even clip volumes, but not with this you can use volumes to clip stuff. So you can even make let's say VDB node, which looks like a cloud here, and now it evaluates. There's this bug until you restart the yeah, it's going to evaluate everything again. Every time you do something, it will evaluate stuff. So let's say density and frustum from camera, let's say, and use the camera. You can see that the camera is creating a volume. This is going to be a volume, which will represent the camera frustum. And you can use a Z near and a Z far. You can use this volume to clip volumes, for example, and use this wrangle to clip, for example, the particles, and use this volume created by the VDB node from camera, use it as a clipping VDB for the volumes that you have in the scene. So there's many ways to optimize stuff. Usually you would optimize the entire scene in the camera frustum, kill off geometry that's outside, except if that geometry should be there, and project shadows and affect the scene entirely. Like if you have like a geometry that is lighting up the scene and you're clipping it outside the frustum, your lighting will change. So you have to be careful with what you optimize. Anyway, this is it for the optimization part. I will recache this mesh with the new optimized particle cache, and the mesh will be even lighter. And I'll probably, because it's a viscous simulation, I'll maybe even disable the adaptivity here, because it's kind of, it makes the liquid flicker. What I noticed in viscous simulation, this adaptivity parameter will try to optimize stuff, and it will yield less polygons. The mesh obviously clearly will be lighter to render, but it comes with a cost, and the cost is flickering in the specs during render. And you'll see that in the final render you'll have the specular pass will be jumping and flickering all over the place because of that adaptivity. So it's not free. So you should know that if you use specular shaders and reflective shaders, this adaptivity parameter is going to mess your render app. So yeah, you can see that we used only the clipped particles for the meshing. So this is what I'm going to save, and this is really important for optimizing the whole thing. So let's save this as a chapter 15 opt, and I'll come up with a solution in the yeah, let's do this. Let me see if I can fix that flickering and come back to you in the same lesson, because I think the 15th chapter is going to be the last regarding the 3D. The next one will be the compositing part. So I played around with these displacement values on the symbiote body, and yeah. The displacement on the ground, it has the mid-level of 0.56. This is what I found to be working. And on the creature 0.5, so we get close to that liquid. And also I reset the ray epsilon to the default value. So the output is something like this. It'll take a second. Yeah, so we have some stuff happening here. All good. So let's render this without motion blur, and we'll avoid that issue that we had before. Reset the view, close this window, and check override. Let's render a V2, maybe with lower settings. In the main, I'll just switch to this render target. Let's render it with 600 samples. We'll do a rough render and then composite it. And in the next lesson, we'll have the compositing part of it. It will be really unorthodox compositing, a really quick slap comp, just for the sake of seeing what's happening. And yeah, that will be it for the 3D part. See you in the next one.